everyone, today we shall be discussing division in modular arithmetics. Unlike other operations we've dealt with in modular arithmetics, division can be quite difficult to deal with without much understanding of the modular system itself. For an instance, in the normal arithmetic, 4 all over 0 equals undefined. Likewise, 4 over 10 is undefined in modulo 6. Except by some manipulation which we shall soon get to see. Let's solve the following examples for better understanding. Before I proceed with the first question, it is important for us to remember that in the previous videos, especially that on inverses of arithmetic modulo, we realized that every element in a prime modulo has an inverse. It is also very important to know that division can be done conveniently on a prime modulo. This first question being an example. It is a clear fact that 18 is congruent to 3 modulo 5. So, should we intend to divide through with what we have in common here, which is obviously 3 here. So if I do that, 3 in 18, I have 18 divided by 3 is equal to 3 over 3 modulo 5. And this will give me 6 equal to 1 modulo 5, which is very, very correct, because this is equivalent to this too. This is possible because the modulo is 5, which is a prime number. It is also possible in a situation where we have the system to have this condition. Divisibility is possible in A equal to B modulo n if and only if the difference between A and B is also divisible by n. With that, we can see that 18 minus 3 will give me 15, which is divisible by 5. Likewise, 6 minus 1 will give me 5, which is also divisible by 5. So that also holds. In fact, that's the main principle of division in modular system. Checking the second question out. Looking at this second question, of course, it's obvious that this is very true. If we intend to reduce this, say reducing with what is common here, let's say 2 is common between in 10 and 4. If I should reduce that, of course we know that this is congruence. Let's see if what we get is going to be congruence. If we try that, this is going to give me 5 equal to 2 modulo 6. If you look at that carefully, you would see that this is not true. It's not true. The first satisfied this first, but this is not satisfied. This doesn't satisfy this rule. So it's not true. So if we find ourselves in this situation, what do? And this brings us to a rule which states, given that A is equal to B modulo n, and if we can write A as Q times C and B as P times C and n as M times C, where this C is the GCD or the HCF of A, B, and N. Then we can divide through by this GCD to give us Q equal to P modulo N. I hope that is very clear. This can be applied on the second example. So from there we can get, since our HCF here obviously is 2, so this becomes 10 over 2 will be equal to 4 over 2 modulo 6 over 2. So we divide, the modulo 2 will be divided. So this becomes 5 equal to 2 modulo 3, which is very, very correct. Why? Because 5 is equivalent to 2 in modulo 3. I hope that is very clear. With this idea we've gathered, let's go on to solve the questions under number 2. To solve this question, 3x equal to 5 modulo 7. To deal with it, first of all, we have to see here that we want to make x subject of the formula, and to do so, we must remove this 3. This 3 must be taken away. But we can't divide through by 3 even though this is an even a prime modulo. So we can't divide through by 3. Why? Because this is not a factor of 3. It's not a multiple of 3. So to proceed on this, the only thing we can do is to multiply by the inverse of 3 in modulo 7. And if you can remember clearly, the last time when we did the inverse, the inverse of 3 in modulo 7 is 5. So this means I'm going to be having multiplying both sides by 5. That's 3x times 5 is equal to 5 times 5 modulo 7. So in this case, this becomes since they are inverse of one another, this is the inverse of this, they are inverse of one another, so this becomes x equal to 25 modulo 7. Of course, we can't have 25 in modulo 7, so we have to reduce it. So this becomes x equal to 21 plus 4 modulo 7. Of course, 21 is a multiple of 7, so it becomes 0. Therefore, my x is equal to 4 modulo 7. I hope that's very clear. Dealing with this second question is quite simple too, since this is it's not a prime modulo, it's not a prime modulo, so we can divide through by, and we can see the GCD of these 3 numbers, 10, 4, and 6, is 2. So we can divide through by 2. So this becomes 10x over 2 equal to 4 over 2 modulo 6 over 2. By so doing, this becomes 5x equal to 2 modulo 3. So now we are to find the inverse. We are going to reduce this. Reducing it, this can be given, this is the same thing as 3x plus 2x is equal to 2 modulo 3. And since this is in modulo 3, all this becomes 0, then this remains 2x is equal to 2 modulo 3. And since this is a prime modulo, we can do our division easily, dividing both sides by 2, which is the common factor here. This becomes 2x all over 2 equal to 2 over 2 modulo 3. And this becomes x equal to 1 modulo 3. I hope this is very, very clear. So that will be all for now. Hit the subscription button if you haven't yet. Like this video. Thanks for watching.